Hello, this is Math 2270 coming to you from the College of DuPage during the summer of 2020, and this is the conclusion of the lecture on reduction. I left you with this example. Order. Many of you probably solved it. I suggested you verify this is a solution and work the problem. You might have gotten distracted and not finished this, so I'll give you an opportunity now. You know what to do. Let's see how you did. And the problem itself is up here. So this time we're going to let y2 of t equal v of t times y1 of t. And in our case, where y1 is 1 over t, this is what y2 is. This is what the first derivative of y2 is using the product rule. And this is what the second derivative is using the product rule multiple times. So we're going to take these values for y2 and substitute them into my equation up here. And that's what we're doing here. And we do the algebra, and I would encourage you to actually do the algebra. You will be required to do the algebra as you execute this process. We will get this expression, and notice that, again, by design, the coefficient of v is going to net to 0, which means I'm left with an expression in v double prime and v prime. That motivates the substitution. W is equal to v prime, and w prime would be v double prime. So making that suite of substitutions into this, we get this expression, and this is our old friend, a linear first order differential equation that we know very well to solve. Now I am skipping the details here, but you should include the details in your work for practice. So we can solve this, and we will find that w of t is equal to a constant times t to the 3 over 2. But recall that v prime was equal to w, and we want to know what v is, and so we're going to integrate w. So v of t is equal to the integral of w. I'm integrating what w was found to be, and I get this expression, and I can pick these constants to be anything I want. And since I'm really interested in the other solution, I'll take k to be 0 and c to be what we get, c to be 5 halves. So I just will get that v of t is t raised to the 5 halves. And that means my second solution then, y2, is going to be t to the minus 1 times that is t to the 3 halves. Now that means we found a second linearly independent solution, and the general solution will be this. And if we had been given initial conditions, then we could differentiate this, apply the initial conditions, and in fact solve for the constants. That wasn't what I asked you to do, but I could in the future. Reduction of order, the method used in the previous example, can be used to find second solutions to differential equations. However, this does require we already have a solution, and often finding that first solution is a very difficult task. And often, in the process of finding the first solution, you also get a second solution without needing to resort to reduction of order. So for those cases, when we have a first solution, this is a nice method for getting a second solution, and we will have at least 3 occasions in this course to do that as we go forward, and one of them will be happening pretty soon. So here's another example. This time you're to find the general solution of this, given that this is a solution, and you should verify that this is a solution to start with, and other than that you know what to do. Let's see how you did. And the problem again is still up here. So we're letting y2 equal t times v. We'll take the derivative using the product rule, and the second derivative using the product rule yet again. We will take these values and substitute them into the original equation, and we will notice that the 2tv term here will cancel with the 2tv term here, and so we're left with an expression in v double prime and v prime. Now that motivates the substitution. W is equal to v prime, and w prime is equal to v double prime, And if I substitute these into the equation, I get the following linear first order differential equation in W. We know how to solve that. I encourage you to go through all the steps. I'm not doing them all here, but you will be required to do that in a problem that I ask you to solve. So when we do that, we will find that W of t is equal to c t to the minus 4. But we need to know what v is. So v is going to be the integral of W, and we will get this. Again, we can choose the constants to be what we want, and so we're going to choose the constant c to make this a 1, and we'll take k to be 0. And what we get is that the v was going to be t to the minus 3, and that means y2, the second linearly independent solution, is going to be t to the minus 2, and then the general solution will be this. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.